Hello, Year 9, and welcome back to what is our fourth angle lesson. In this lesson, we are going to be looking at triangles again, but more particularly, some special types of triangle. So first of all, let's see if you do know what different type of triangles there are. So for a little starter activity, we are going to be looking at the names, descriptions and diagrams for different types of triangle. Now I've jumbled this all up. I've given you the names of 4 different types of triangle. I've described that triangle in words and I've also drawn a picture. So what I would like you to do is pause the video here and see if you can match the name, description and diagram, and then I will go through the answers. So pause here. So let's see how well you've managed to do with these. I'm going to go through each of these with the names in turn. So the equilateral triangle. An equilateral triangle is a triangle where all the angles and the sides are the same length. So the equilateral triangle matches to this description here. And which triangle looks like the one where all the sides and the angles are the same? That is number 4. Let me grab a different colour. Isosceles. So the isosceles, probably the hard one to spell, is a triangle that has 2 sides and 2 angles the same. So this one matches to the one at the bottom, a triangle with 2 equal sides and angles. Well, what does that one look like? That one is number 1. The third type of triangle that I've written down is something called a scalene triangle. And this is the most irregular of all the triangles. So it's one where all the sides and all the angles are different. Okay, and that was triangle number 3. And finally, that leaves the right angle triangle, and a right angle triangle is pretty much exactly what it sounds like. It is a triangle with a right angle. So that one must be the triangle that has an angle of 90 degrees. And it is that one there. And I'm sure we are used to seeing right angle triangles. So as I said, for today, we are going to be working out missing angles in triangles, but we are going to be looking at 2 very, very special examples of triangles. So I hope you've managed to print out the sheet for today that goes with the lesson. And if you haven't, I'm afraid, once again, title and objective into your book, and you will need to copy the key information down. If you are drawing any diagrams, of course, use a pencil, use a ruler. So the 2 special types of triangle we are looking at today are the equilateral triangle. And an equilateral triangle, as we've already said, has all the angles the same size. And because the angles in a triangle have to add up to 180, it makes them all 60 degrees. Which means an equilateral triangle actually doesn't come up very often in questions or in exams, because all the angles are 60 and you're pretty much done. There's nothing to work out, but it can occasionally pop up, so it is worth knowing that in an equilateral triangle, all the angles are 60. We can denote an equilateral triangle by putting a little mark on all of the sides of the triangle. That tells you that all of the sides are the same length, and I sometimes refer to these as little whiskers. Okay, so that is your equilateral triangle. The one that we will be seeing a lot more of today is the isosceles triangle. Well, how can I tell that this is isosceles? Well, it's because it's got the 2 little whiskers here and here. And that is telling me that those 2 sides are the same length, so it must be an isosceles triangle. And in an isosceles triangle, there are always two equal angles. Now, most of the time, you'll be able to look at the diagram and spot which two angles look the same. But if you were ever unsure as to which two angles are the same, what I sometimes suggest you do is you mark on with a different colour one of the lines that has the whisker, mark on the other line that has the whisker. Now those two sides will always meet at an angle. That angle is the unique one, the one that doesn't match. It is the other two angles that are always the same. So let's see how we can apply this bit of knowledge in some angle questions. So, examples: calculate the missing angles, show your working out. And my top tip, if you are dealing with an isosceles triangle, is always think about which two angles must be the same size. Well, first of all, how do we even know that this is an isosceles triangle? Well, it's because we have the little whiskers. Two whiskers on two sides, those two sides are the same length. It is isosceles. Which two angles are the same size? Well, it is these two here. So there isn't a great deal of working out for this question. A has to be 68 degrees because those two angles are the same size. Let's look at the next question. Again, we've got an isosceles triangle because we have the little whiskers. But which two angles do we think are the same this time? Did you guess it right? It is these two. Remember what I said? Look at the sides with the whiskers. That is the unique angle. So these two must be the same. That means B is really easy to work out. Because it is the same, it has to be 56 degrees. But how are we going to work out C? Well, this is where we need to recall our knowledge from last lesson that the angles in a triangle add up to 180 degrees. So if I now add my two 56s together, 56 and 56 makes 112. So I can work out C by subtracting that from 180, which is 68 degrees. See, even I almost got that wrong. 68 degrees. If you're not confident doing something in your head, then write out a written method, please. So let's look at a couple more challenging questions, the sort that some of you might get onto today. So we've got this triangle here, and this time I've told you the top angle is 20 degrees, and we've got E and F. And E and F are the two angles that are the same size. So how do we go about doing this question? Well, if we know that this top angle is 20 degrees, we first of all need to think about what is left. Well, we know the angles in a triangle add up to 180. So if we've already used 20 degrees, there is 160 degrees left. If these two angles are the same, they must both be a half of this. So if I divide it by 2, I will be able to work out what E and F both are. So E must be 160 divided by 2, which is 80 degrees. And F must be the same. So they are both 80. If I wanted to really double check, I could see if all of these angles added back up to 180 degrees. Now, in my final example, I've got a kind of squashed isosceles triangle. I know it's isosceles because there are two whiskers, but I've got this extended line. So we know we've got 180 degrees here because there's a straight line. So I'm just going to work out this extra angle first. And I know that extra angle must be 180 degrees, take away 155. And when I subtract that number, I am left with 25 degrees. So this angle here is 25 degrees. How are we going to work out G? Well, G is the same as 25 degrees because these two base angles in my isosceles are the same. So G is 25. So how are we going to work out H? Well, we know that these two angles are now 25. If we add those together, that makes 50. So we need to see what's left in our triangle. So that is 180. Take away 50, which is 130 degrees. So please look back at my instructions for today. There are some questions over 2 slides in the PowerPoint, so please follow the link. Will you make sure you draw out the diagram? Will you make sure you show working out, please? You shouldn't really be using your calculator, but I have no problem if you want to at the end of each question. Use your calculator to check your working out. Always think about which 2 angles are the same angle. And of course, if you have any problems, remember you'll be able to contact me or your teacher in the Ask the Teacher channel.